So the next topic is going to be query execution parameters. First, let's have a level set. So what are parameters and its values in a particular query? I hope you already know this, but just to reiterate. So if this is the query where I'm selecting multiple columns from a table, whatever we mention in the where condition, the left hand side of the equal to sign are the parameters, and the right hand side are the values of those parameters. Now in this case, customer ID is the parameter and 123 ABC is the value. Similarly, payment method is the parameter and MX is the value. So these are query parameters and its values. Now why am I talking about this? Because there can be scenarios that if you want to execute a particular query, every time the value of a particular parameter would be different. For example, if I talk about this particular query, here I have used customer ID to be 123 ABC, but maybe next time I want to use some other customer ID. Same is the case with payment method also. So what you want to do is that you want to execute the query multiple times, but every time the parameter values would be different. So of course you'd not query with the same parameter value every time. Instead of editing the query itself or its parameter values, for example, every time if you have to run this query, you have to change the parameter value. So next time it can be 678 and DEF as the parameter value of customer ID, and payment method can be Visa. So instead of changing the query itself, we can use query execution parameters. So what do we do there? We place question mark in the place of parameter values. So this particular query that I'm showing you here would be changed to this. Instead of putting a value for the customer ID and payment method, I have put question mark here. So you write the query like this, and then while executing, we pass the parameter values. The parameter value or query execution parameters are valid for select statements, insert into statements, create table as statements, and unload commands also. I have not talked about unload commands yet, which is the next topic. Query execution parameters can be set for these different query types or these different SQL statements. Now, as I said that you want to run the same query multiple times in a particular day, and every time you want to change the value of the query parameters, typically what happens is that when you run a query in Athena, an explain plan or execution plan is created. So if you want to avoid that every time the execution plan would be created, we can use prepare and execute statement, which again we'll see in this particular topic itself. So prepare and execute statements also support query parameters. The next one is unload command. So basically, first of all, the question is why would you use unload command when you have the file already or you have the data already in S3? So does it make any sense to use the unload command itself? The answer is yes, because what you can do is, let's say you are running aggregate queries, like you are doing a group by, you are doing sum, average, you are running window functions, etc. So instead of running it every time, execute it once and let's say save it or save the output in a different location physically, and then query that or create a table on top of that and then query it using the table. So similar to kind of materialized view. So unload command essentially extracts query results from select statements in a specified format. Now this is the second important reason for unload command. We can mention a different file format also. And these are the various parameters. The format, which is basically the file format that I want to save the query in. So let's say we have a input file in CSV format, and let's say you have multiple tables which are pointing to different S3 locations, and then we are running a complex join query or complex aggregate query based on all those tables. So what we can do is that we can run a select statement using joins across all those tables, and then or run an unload statement rather on that particular select statement and save that query output in, let's say, Parquet format in a different location. Then we also mention the compression, like it can be gzip, snappy, etc. Then we have compression levels and field delimiter, which is typically used for CSV file format. And this is the syntax of the unload command. So you mention unload and then select statement, which is put in the bracket. So if you see, after unload, we have this entire select statement inside of bracket. So the select statement has to be placed here. And then we mention the location. So let's say we want to mention that unload or save the output of this particular query result to this location in S3. And then we mention the format or various parameters using the with clause. So after with clause, we mention format, we mention the compression algorithm and field delimiter if needed. And as I said, prepare and execute statement. Now the question is, why do you want to use prepare and execute statement? What it does, it creates SQL statement to be run at a later time. It is a very simplified way of saying it. Just to give an example, as I said in the query parameter, so let's say you have that particular query which will be running, let's say, thousands of times in a day, or maybe thousands of times in a month or 4 months, because Athena is typically used for ad hoc query. It's not that you'll be using Athena as a data warehouse, but you'd run Athena on an ad hoc basis. So let's say the same SQL statement is run thousands of times in maybe 3 months, 6 months, etc. And it is the same SQL statement. So what would happen is that if you run it every time, Athena would go through that cycle, that it would parse the SQL statement, create the execution plan, and then send it to the workers, right? So in Athena is basically Trino behind the scenes. So there will be a coordinator node and then worker nodes. So every time if you run the query, then it would be sent to the coordinator node, and coordinator node would create the access plan every time. Instead of doing that, we can use prepare statement, and if you prepare the statement, the access path would be saved, and every time we can pass parameter just to execute the query, or we can execute the query later on. If you do not have any parameter, if you have simple SQL statement also, that is also fine without query parameters. You prepare the SQL statement once and then execute it maybe thousands of times. So the query plan would remain the same. So query parameters can also be included in the statement, as I mentioned earlier, and I had told this about in the query parameters also. And this is how the statement would be: prepare followed by the name of the statement, then from followed by the SQL query. Now this SQL query can have query parameters also. The supported SQL queries are select statement, create table as statement, and insert into statement. These are the only SQL statements which are supported by prepare. And query parameters can also be used using the question mark. And then we execute the statement multiple times using the statement name that you have given in the prepare statement. So like execute the statement name. If you do not have any query parameters, then you don't have to mention the using clause. So anything beyond this using clause is not needed if you are not using query parameter. So if you are using query parameter, then I'll have to pass the parameter values one after the other. So here I am showing you three, because let's say in the SQL query there are three query parameters: customer ID, payment method, and order date. So that's how the parameters are. That's how the where condition is. Customer ID is first, then the payment method, and then the order date. So in the using, or basically the values should be as per that. The first one should be the customer ID, then the payment method, and then the order date. And then you can pass the parameters and execute the statement. Then we have schema evaluation. So basically schema evaluation is nothing but handling schema updates. Athena actually enforces schema on read. So meaning that schema is applied when the data is read. When the data is written, it is written in S3. So it might so happen that there is no schema that was defined on that particular table. Only when you read, the schema would be applied on the data that is lying underneath in S3. And if the column matches, then it's fine. If the columns don't match, then it will be shown as blank. If the value is not correct, then it will be shown as blank. So these are the supported schema updates in Athena. So we can rename columns, we can add columns at the beginning or middle of the table, we can add columns at the end of the table, we can remove columns, we can change the data type, and we can change the column position also. And these are the popular file formats: CSV, JSON, Parquet, Avro, and ORC. And you can see which are supported where. For example, rename column is not supported in Parquet because in Parquet, Avro, and ORC, we already get the schema in the file itself. Same is the case with JSON also, because JSON file contains the keys or the attributes and their corresponding values. So that's why you cannot rename the columns. We can add columns at the beginning or middle of the table only for JSON, Parquet, Avro, and ORC, but not for CSV. So you can pause this video and take a look at this particular table, which are supported where. Final topic for this video is querying JSON. So you already know what JSON is. JSON is JavaScript object notation. And if you do not know JSON, just to give you a overview, so any JSON document starts with curly braces and ends with curly braces. And inside of this, we have these fields. First is the name, followed by its corresponding value. This is the column or the attribute. Address is another column or attribute, and it has a value which is also a JSON document. And we call these as embedded JSONs. So that's why I have color coded address, because that's a different data type, which is an embedded document. Now inside of it, again, we have attributes or keys and their corresponding values. Like ADDR1 has Bangalore, ADDR2 has India. So these are the two keys and their corresponding values. Phone is also another key, but the value of phone is an array with value 1, 2, 3, 4 and 5, 6, 7, 8. And then again, it closes the curly braces. So the column address has this particular value with 3 keys and their corresponding values again. So this is a single record in JSON. And if you have, let's say, millions of records, there would be millions of documents as such. So address here is also a JSON. Now we call it as embedded JSON, and phone here is an array. So address can also be called as a nested document, and phone is basically an array inside of that nested document. When you use JSON, we have to use create table with the data type struct. I have not talked about struct yet, but we need this data type struct to create the table, or it has to represent a file with JSON data. And then we do the query using dot notation. And we query the arrays using square bracket followed by the index. So let me give you some example. Let's say you want to get address 1 and address 2, or ADDR1 and ADDR2, which are keys inside of the address key. So what I have to mention, you have to mention the address key dot the ADDR1 key. So that's what the dot notation is. It will be like this: select address.addr1 followed by address.addr2. Now how the array would be, let's say we want to get the second phone number, which is 5678. We'll use square brackets that I have mentioned. So it will be like address.phone, because phone is again inside of that embedded document, which is address, and then the square bracket number 2. In Athena, the index starts with 1 rather than 0. Now, if you do not want to store JSON as struct data type, you can also store it as string, and then you can use various parsing method to parse the record. But as a best practice, you should use the struct data type to store JSON documents.